Hello, today we're going to learn about significance tests, and we will continue to use them for the rest of the year. So today we'll learn the parts, tomorrow we'll learn how to put them together, and then for the rest of the year we'll be using them. Now, what a significance test is a a formal procedure for comparing observed data with a hypothesis whose truth we want to assess. Here's an example that we'll be using the rest of the day. Several cities had begun to monitor their paramedic response times. In one city, the mean response time to all accidents involving life-threatening injuries last year was 6.7 minutes, with a standard deviation of 2 minutes. The city manager shares this information with the emergency response personnel and encourages them to do better next year. At the end of the following year, the city manager selects a simple random sample of 400 calls involving life-threatening injuries and examines the response times. He finds a mean of 6.48. Does this give good evidence that the times were improved? Now find the mean and standard deviation for the sampling distribution expected for 400 samples. Well, the mean of 400 samples, so that would be the mean of x bar, would be 6.7. Assuming 6.7 is true, that's what we would expect to get. Now, our standard deviation of x bar, we would get, take our standard deviation from above, which was 2, and divide it by the square root of 400. Now, when I take 2 divided by the square root of 400, I get 0.1. Now, how many standard deviations away that is? That's a little over 2 standard deviations away from the mean. So is that likely to occur? Hopefully you're saying no. 6.48 is way out here, so for that to occur, it's a very rare chance that that'll happen. If the data point was 6.61, we could say that this is likely to happen. Out here, it's pretty rare for that to occur. Now, when we write up a formal writing on this, we have to know about the null and alternative hypothesis. The statement that being tested in the significance test is called the null hypothesis. The significance test is designed to assess the strength of evidence against the null hypothesis. Usually the null hypothesis is a statement of no effect or no difference or no change from historical values. The claim about the population that we're trying to find evidence for is called the alternative hypothesis. In short, we write H sub 0 as null hypothesis, H sub A is alternative hypothesis. In the paramedic example, let's find the null and the alternative hypothesis. So for our null hypothesis, we want to say that the mean will be 6.7. For our alternative hypothesis, we want it to be less than 6.7. So this is the historical thing. We're going to say that nothing has changed. And we want our alternative hypothesis to say mu will be less than this value, than that value, 6.7. Now we can't just leave this alone like this. We'll have to say what mu is. Mu is the mean response time for paramedics. Now hypotheses always refer to the population, not a particular outcome, so it's in terms of mu rather than x bar. Be sure that it's always in terms of the population parameter, and we did that by having a mu for our mean. Alternative hypotheses can be one-sided or two-sided. One-sided hypotheses are when the alternative hypothesis is either greater than or less than, and two-sided is when it's not equal to. Now, this is another example. Does job satisfaction of assembly workers differ when their work is machine-paced rather than self-paced? One study chose 18 subjects at random from a group of people who assembled electronic devices. Half the subjects were assigned at random to each of the two groups. Both groups assembled work. One group setup allowed workers to pace themselves, and the other featured an assembly line that moved at a fixed time intervals, so the workers were paced by machine. After 2 weeks, all subjects took a survey. They switched work setups and took the survey again. The parameter of interest was the mean of the differences in the scores. What method is this? This would be a matched pairs design, where both get the treatment and the control. Now let's look at the null hypothesis and the alternative hypothesis. The null hypothesis is the mean is going to be 0. We're going to say that there's no change that occurred. The alternative hypothesis is just going to be the mean that is not 0. So what we'd want to say is mu is the mean difference, or it's the mean difference in satisfaction scores. So we have to say something about mu being the mean difference in this one. All right, for conditions, we still want to check SRS, normality. For means, we want n to be greater than 30. For proportions, np greater than 10, n times 1 minus p greater than 10. And for independence, we want to make sure that n is greater than or equal to 10 times little n. Same as confidence intervals. Now, does the paramedic example pass the conditions? Well, let's go up to the paramedic example. It says that he took a simple random sample. That's our SRS. So we have that. It has 400 calls, so n is greater than 30. That looks good. Central limit theorem will say that's approximately normal. And we'd have to assume that there's more than 4,000 calls to the paramedics within a year for each thing to be independent. All right. Now if we go to a testing system, finding values that show how far away a value is from the estimated mean. Now let's find the z-score for the paramedics. Now for the paramedics, we got 6.48, and we want to subtract the mean that we had before, which was 6.7, and divide it by 2 over the square root of 400, which we already said was 0.01. So this would be negative 0.22 over 0.01. Oh, not 0.01, just 0.1. I'll write that again, which will come out to be negative 2.2. So that's the z-score of that one. So it's pretty far from the mean. P-value is the probability computing that the null hypothesis is true, that the observed outcome would take place as extreme, or would take a value as extreme or more extreme than the actual observed value. That's called the p-test, p-value of the test. The smaller the p-value is, the stronger evidence against the null hypothesis. Find the p-value in the paramedic. So that's the probability that my z-score is less than negative 2.22. So you do a normal CDF from negative big number up to negative 2.2. And I got 0.0139. So about 1%, a little over 1% of the time that will occur. Now in the job satisfaction survey, it was two-sided. Now the standard deviation of the study was 60. For 18 people in the study, the mean difference was an X-bar of 17, as they prefer self-paced environment on average. So first, the probability that my z-score, now we get, if we take a look at this, our null was 0. And 17 was the observed difference, but the standard deviation was 60. So if this is 60, 17 will just be like right there. Since this is a two-sided, we'll want to see how extreme this is. So we'll find the probability that is out here, or the probability that's right here. So we take 17, probability z is greater than 17 minus 0 divided by the standard deviation, which is going to be 60 over the square root of n. And there were 18 people in that survey. So that would be 17 divided by 60 over the square root of 18, which is 1.2. So that's the probability that my z-score is greater than 1.2. Now, if I want to find if a value is as extreme, I'll have to multiply both these by 2 to get my p-value. So I'll find my probability of taking a normal CDF from 1.2 to a very big number, and then multiply that by 2, and I got 0.23. So about 23% of the time, I'll get a point as far away as we got in the job satisfaction survey. Now, a significance level is the decision level for the p-value. We write it as alpha. Alpha equals 0.05. Now, if p-value is as small or smaller than alpha, we say the data are significant, statistically significant. Significance does not mean important, it just means that it's not likely to happen by chance. So what are good levels for alpha? 0.05 is the standard. However, it depends what industry you're in. If sometimes if you don't need to be too precise, 0.1 is good enough. However, if you are in an engineering world and you cannot make a mistake, you might want to have a very, very precise alpha level. So it depends on what your study is about and how important your results are for what your value should be. All right, now once we get our p-value, we have two decisions. We can either reject the null hypothesis, or we can fail to reject the null. We never accept the null or accept the alternative hypothesis. We either reject it or fail to reject the null. If you're going to state conclusions based on statistically significant data, the significance level should be stated before the data are produced. All right, that should get you through the homework. Good luck.